So when it says find the roots, you're just going to factor. But remember, if you can't factor, you can solve by completing the square, or you can do the quadratic formula, or you can do the square root. But I'm the type of person where I know how to factor and it goes quicker, so I would rather factor. So negative 3xx, 3x. The 3's and the x's are the same. But I don't like my x squared to be negative, so I'm going to put that there. Then I'd be left with an x, but since I have to acknowledge the negative, that positive turns negative. If I set it equal to 0, I get x equals 0 and x equals 3. And I want to show you how to check it. So go on, anytime you have a graph, delete it, Control G, negative 3x squared plus 9x, enter, menu trace, graph trace. Now if you look, one of my zeros is 0, 0. Let me just check the other one because I want to make sure. And one of my zeros is at 3, so I know that I did it correctly. Okay, let's go to the next one. I'm somebody who likes to factor, so I take out a 5. You don't need the 5 to get the x. This is square root, x minus 5, x plus 5, set it equal to 0, x equals 5, x equals negative 5. Now I want to acknowledge that I think some of you would add 125 instead, divide by 5, get 25, square root, and you think that's easier? Fine. Letter C is cubic, but all we've been doing is quadratics. So obviously I need to make sure I take out an x, and then I'd be left with x squared minus 6x plus 9. If I set that equal to 0, I get 0. But I still have a squared here, so I have to factor. Put x. Two numbers that multiply to 9, but add to 6 are 3 and 3. The way to get that negative is go negative 3. Since these are the exact same answers, I just need to write it one time. X equals 0, x equals 3. Letter D, I think you want to solve by completing the square, but I'm the type of person that would rather factor. So I'm going to add 24. Two numbers that multiply to get 24, but add to 10. Set it equal to 0. So I got my two answers, negative 6 and negative 4. What I want to show you is how to check it in the calculator. So menu, actions, delete all, Control G. Now if I'm going to graph this in the calculator, x squared plus 10x, I have to make sure it says equals 0. So I can't check that. I have to check that answer. And then when I graph it, menu trace, graph trace, down. Oops, almost there. Negative 4, and then I know 2 more is negative 6, so I'm good to go. All right, subtract 8. 3x minus 5 squared equals 72. Divide by 3. X minus 5 squared equals 24. Square root. I got to tree that, and I get 2 rad 6 plus 5. So x equals 5 plus or minus 2 rad 6. But you know I got to split it. So I'm going to go home, calculate 5 plus 2 rad 6 is 989, but it rounds up, so it's 990. And then I go up, enter. 5 minus 2 rad 6. Oops, I did that wrong. Okay. 5 minus, and I get 10 cents or 10 hundredths. Okay, you know I'm going to check this one. So I'm going to go graph, menu, actions, delete all, Control G. I'm going to start typing. Okay, now remember I said it has to say equals 0. So if I'm going to check it in the calculator, I have to bring this 80 over there, which means I'm subtracting 80, which would turn into minus 72. This is just for check. That's kind of crazy, but who cares? Menu trace, graph trace. If you look, it actually started at my 0, which happens to be 10 hundredths. So, I mean, the likelihood I'm going to get 9.90 wrong, I mean, it's just like a 10%, a 1% shot, okay? So don't worry about it. Okay, Last one. When I look at it really quick, it doesn't lend itself to factoring, which means I would want to do the quadratic formula. 4 times a times c all over 2 times a. You know I like to simplify this. Square root of 9. A negative 441 is 16. Now, here's what I want you to see, which you can't see, sorry about that, is that when I get a perfect thing, a perfect number in the square root, that means I could have actually factored it. So 3 plus 5 is 8 over 8. 3 minus 5 is negative 2 over 8. 8 over 8 is 1. Negative 2 eighths is negative 1/4. Don't leave me negative 2 eighths. I'm sorry you can't see that. So 8 over 8, 1. Negative 2 eighths is negative 1/4. That one feels a little sketchy for me, so I think I'll graph that one also. Menu actions, delete all. Control G. 4x squared minus 3x minus 1. Menu trace, graph trace. And I'm going to check that one, which the 0 told me negative 0.25. Well, 25 cents is like a quarter, so I know I'm good to go. Okay? Remember I had you change this one to y equals 3x squared minus 25. So you're finding the roots. That's the question. So set it equal to 0. Add 25. Divide by 3. Square root. X equals plus or minus 5 over rad 3. You can't have a radical in the denominator. So rad 3, rad 3. So x equals plus or minus 5 rad 3 over 3. I need the perfect answers. So I'm going to go on, calculate, control divide, 5 rad 3 over 3. Now if it's the same thing plus and minus, I just write 289 and negative 289. I can check this, but I'm just hoping I'm right now, just for time. Okay, graphing. Now if I'm going to get to graphing, you know the first thing I'm going to do is opens up. Because of the 3, showing my work, I'm going to get through what I can. The axis of symmetry, the vertex, they're all associated. And so I can't do that right away, so I'm not going to. The x-intercept is a workout. I'm not going to do that right now. But the y-intercept I can get just like that. 0, 6. Domain, all real numbers. Negative infinity to positive infinity. The range, y is greater than because it's going up. I need the y value of my vertex. Intervals, dependent on my vertex. I'll wait for that. End behavior I can do as x approaches negative infinity. F of x approaches positive infinity because it's going up. As x approaches positive infinity, f of x approaches positive infinity. So I did what I could that was no problem. I'm going to do the x-intercepts right now because I feel like it, but I also don't want to make mistakes. So I'm probably going to graph it first. Menu actions, delete all. Am I sure? Of course. Control G. I'm going to graph it just because I want to see what's going to happen here. And when I see that, ooh, it's not even touching the x-axis, so that means I should have imaginary answers. So I'll start with that. And actually, I can go menu trace, graph trace, and copy the vertex. I know the y-intercept. Cool, I'm good. Ooh, they told me the minimum is 1, 3. So if they told me the minimum is 1, 3, I have the axis of symmetry. I have the y value of my vertex. I can tell you that it goes from 3 to positive infinity. My intervals, I'm a visual learner, are based on that 1, 3. And this is negative infinity. And this is positive infinity because it's based on the x-axis, or the x values. So I notice it's decreasing from negative infinity to 1. And it's increasing from 1 to positive infinity. Okay? I've technically filled in everything except for the x-intercepts, and of course I'll show work for vertex in a minute, but at least I know where I'm coming from here. The only problem is because this is imaginary, I can't check my x-intercept answers. So I better go slow. So I'll go slowly. 0 equals 3x squared minus 6x plus 6. I'm going to divide by 3, so it makes my answers a lot easier. Okay. I can see that I can't factor it, so I'm either going to have to solve by completing the square or the quadratic formula. Remember, completing the square simplifies everything. So I'm going to do that. I move it over. I make my cute little box, whatever, plus 1, plus 1. So that's negative 1 equals x minus 1 squared, what you'll do with the box. Square root, square root. Ah, there's my imaginary. Negative means I. The square root of 1 is 1 plus or minus equals x minus 1. Add 1 to both sides. Okay. And so I get 1. I don't want to put the 1. 1 plus or minus I. Those are my x's. Okay. Now, with that being said, I now have to show my vertex. So all of this was related to my x-intercept. Now I'm going to do my vertex. Well, I remember the formula is negative b over 2 times a. So my a is 3, my b is negative 6. So negative b over 2 times a is 6 over 6, which is 1, which is what I got, but now I'm showing work. Now I'm going to show that I can get the 3. So 1 squared is 1, times 3 is 3. 6 times 1 is 6. Oops. 3 minus 6 is negative 3, plus 6 lends itself to get the 3. Now I've shown all my work. Now I can graph. So I graph 1, 3, 1, 2, 3. I graph the y-intercept, 4, 5, 6. Now, since I cannot use the x-intercepts to help me graph, I have to find the match. So if this is a distance I went left 1 and up 3, I need to go right 1 and up 3. Show my graph. Make sure you label the axis of symmetry. Okay? All right. Last problem. Identify the number of answers you're going to get. So let me show you what that means visually. This is one real solution. It touches 1 time. This is 2 real solutions. It touches 2 times. This is 2 imaginary answers. It doesn't touch at all. And this one isn't even possible. So I need to figure out what the x's are. This lends itself to the quadratic formula. So negative 7 plus or minus 7 squared minus 4 times 5 times 1 all over 2 times 5. So I'm focused here. And I get the square root of 49 plus 20, which is rad 29. Now, sorry, over 10. I don't care about the whole answer as much as I care about I can actually split this and get 2 real answers. So my answer is B. But what I want to point out is it would be 1 real solution if I got 7 plus or minus the square root of 0 over 10. Because the square root of 0 is 0, so it would only lend itself to 1 answer. If I had 7 plus or minus the square root of negative 209 over 10, this would imply that my answers are imaginary. That's too complex. Okay? So be aware. If what's inside the radical is positive, you can literally get 2 answers. If what's inside the radical is 0, well, you can't add or subtract anything, so there's just one option. And if there's a negative inside there, that's imaginary. That's complex.